The first 4 questions are calculator allowed. I don't really care what order you do the quiz in though. So we're going to go on the honor principle that you'll only use the calculator if you're doing the first 4. If you want to save them for last, I'm cool with that. I really don't care. Just only use the calculator on those 4. What do they give you for number 1? It's what do they give me? What do they want? They gave velocity. They want acceleration. How do you get from velocity to acceleration? Derivative. How do you do? It's calculator. So how do you do a derivative in the calculator? Yeah, I'm not going to actually do this whole problem because for time, but you would do math 8. You would put this in such that 2. Boom, that's your answer. Cool. Moving on to the next one. We don't have enough time, right? What did they give us for this one? Velocity. How many times does a particle change direction? That's when the velocity changes sign. So that's when it would go from above sea level to below sea level or vice versa. Do you get what I'm saying? So you would type it in. You would make your window be -5 to 5, and you would just count them. Okay? There's another one on here that's exactly like that later on. So I am going to skip typing that again for time reasons. But you would just type that in. Don't do a derivative. Just look at it from -5 to 5 and just count how many times it crosses the x-axis. That's it. Yeah.
I think I have the I'm sorry.
All right. What they give us for the third one? Position. They want. Oh, this is interesting. We're going to have to actually work this one out. What is the velocity when the acceleration is 0? We're going to need velocity and acceleration. We have to actually work this one out. Okay. So velocity, what's your derivative of sine? So it would be 2 cosine t plus 2t. Good. Now let's go to acceleration. Derivative of cosine, negative sine. So it'll be -2 sine of t plus 2. I'm going to set that equal to 0 because it said acceleration is 0. Like literally just following what it says there. Now to start solving that, you would subtract 2. This would be -2. And then you would divide by -2. -2 divided by -2 would just be 1. So I want you to think about your unit circle. Sine is the y value. Where is the y value? 1. I heard somebody say it up at the top. So pi over 2. Now, what do I do with that time pi over 2? Read back through the problem. We said acceleration equal to 0, but it says, what is the velocity at that time? So you're going to do velocity at pi over 2, and whatever that gives you is your answer. You're allowed a calculator. Okay? Yep. No. Plug it into the velocity right there. Although, let me address that. You could do a math 8 such that pi over 2, but you would have to put this in. Does everyone understand why? Okay, so that's an option as well. When you get a calculator, sometimes there's a lot of different ways you can do stuff. Okay. All right, last calculator one. What do they give you? Position. What is the velocity at the time when the particle is at the origin? So here's what I'm going to do. I'm going to go to y equals. I'm going to type in that position function. I know it says t, but we're going to type x. And then did they give a window? If there's a window, you always want to abide by that. Is there a window? No. So if there's not, I usually hit zoom 6. That puts it back to standard -10 to 10. If you do zoom 6, it says standard right there. Then you can mess with it as necessary. Okay. But it says particle is at the origin. That means we would want this to equal what? 0. Do you see how it's right there? How do I make my calculator give me that? Because now it's not hard to do the problem. You're like, hey, it's right there, but it's button pushing that's difficult. How do you get your calculator to tell you that number? It's the button trace, but you want calc right above it. So second trace, and we're going to choose which thing? 0. Now it's going to ask you left bound, right bound, guess. I do this manually because I don't like messing with the arrows. Do you see how it's in between 0 and 1? So for left bound, hit 0, enter. For right bound, hit 1, enter. And for guess, you can put anything your heart desires that's between 0 and 1. I'm just going to put 0.5, enter. And it will tell it to you. Do you see that there? 0.3176722. I'm going to write down all of that. Because that's actually not the answer. I bet you it's one of the choices. But we found the time when the particle is at the origin. Read back through the problem. What does it want? Velocity. That means we need math 8. And I'm just going to talk you through it. You would do math 8. You would put in this equation, bless you. And then what would you put in the such that bar? That number, and it will tell you the answer. Okay? Math 8, put this equation in, use x's though, and then put this number in the such that bar. It'll tell you the answer. Okay? And even if you don't put all the decimals, when it's multiple choice, it'll get you close enough. All right, those are the calculator ones. On to the non-calculator. What did they give us for number 5? Position. They want average velocity. That is not calculus. How do you do average velocity? Slope. You're going to get a 0.0, whatever. Well, when you plug in 0, you're going to get 0. And then plug in 2. 2 cubed is 8. Negative 16. And then you would do a slope. Okay? Slope them. Y2 minus Y1 over X2 minus X1. That's actually what we're doing in Algebra 1 right now. All right, what are they? Oh, go ahead.
You would use your position for that, not you would find the derivative of that.
That would give you a second derivative.
Okay.
All right, what do they give you in number 6? Position. They want at rest. What does that mean? Good. All right, so let's get velocity. This is heavy on the algebra, not really so much the calculus. The only calculus is finding the derivative. After that, it's all algebra. What's your derivative for that thing? 3t squared minus 18t plus 15. Those will all divide by 3. So that would be t squared minus 6t plus 5. Could you keep going? Like, okay. Times when your velocity is 0. Using the same equation as number 6, so we're going to use that one. What do we know about the particle's motion at time 2? We're going to look at velocity at 2 and acceleration at 2 and then see what that tells us. And you don't need to find an actual number. It's just, is it positive or negative? Okay. Okay. So we're going to do velocity at 2. And again, you don't need to figure out what it actually is, just positive or negative. So if you plug 2 into this, 2 squared, 4 minus 12 would be negative 8 plus 5. It's going to be negative or less than 0. All right, now we actually need to find the acceleration. I don't have that equation yet. Go back to your velocity, do another derivative. What's your derivative of this? Good, 6t minus 18, and I'm going to plug 2 into that. And I don't need to figure out what it actually is, just if it's positive or negative. So if you plug 2 into that, 12 minus 18, negative. Velocity tells you which way it is moving. So if it's negative, it's moving left or downwards or in the negative direction. It'll be multiple choice. So whatever it says, moving left, and is it speeding up or slowing down? Good. Oh my gosh, you guys got that. Why is it speeding up? Oh my gosh, oh, you guys, that's the most commonly missed thing, and you guys know. Perfect. I like it. Same sign, speeding up. Yep. Well, it'll be multiple choice, but yeah. So your choices will be like moving left, slowing down, moving left, speeding up, moving right, slowing down. All right, which this one's kind of similar. Position is bigger than 0. So position is positive. That just means you're, to the right of whatever. Let me see how they worded this one real quick. Like the way it's worded on the quiz, which I didn't write it on here, is where is it from the origin? So if it starts out that the position is positive, it means it's to the right of the origin. Like here's 0, it means the particle started out over there. If your position's positive, it means it's somewhere in the positive direction. Derivative means it's moving to the right. So it's going that away. And then this is acceleration. Oh, but acceleration is pulling you to the left. So it's moving away from zero, but it's doing what? Slowing down. So away from zero and slowing down. That's how they word it. How is it moving in relation to zero? So for example, if it started out to the left of zero and it was moving left, it would still be moving away. You know what I'm saying? Okay.
So
Just
by
positive.
taking away, it's not saying it's positive or negative, it's just saying it's moving away.
Velocity just tells you the direction. Positive velocity means moving forwards or to the right or upwards, whatever the context is. Negative velocity means moving in the negative direction.
As for the derivative, you have x or the first derivative.
X prime negative 4, like, are you?
Going to the positive, so it could be.
Oh, it could be moving towards it. Yeah. So like if it started out here, but velocity was negative, it would be going that way. It would be moving towards zero. Yes, just whatever they give you. All right. What do they give you for number 9? Position. What are they asking for? At rest. That is when velocity is 0. So we're going to get the velocity, set it equal to 0. You don't get a calculator for this. So what is your derivative of cosine? All right, so it's going to be negative sine pi over 2t times, what rule is that? Chain rule, good. Minus, what's your derivative for pi over 2t? Pi over 2. We're going to set that equal to 0. So how would you start solving that? Now we're back to like algebra here. Yeah, you would add over the pi over 2. Now, what's a like cleaner way I could write this? Because I did the chain rule and chained that on, but I should really just write negative pi over 2 out front. All right, then what? We want to keep on going. You would divide both sides by negative pi over 2, which is going to give you negative 1. So you need to think about your unit circle, up, down, left, right. Sine is the y value. Where is sine negative 1? Down, which is good, 3 pi over 2. Still with me? I got pi over 2t equals 3 pi over 2. The pi's cancel, the 2's cancel, and so you get t equals 3. Again, be multiple choice. All right, number 10, what did they give you? Position, they want acceleration at time 6. I'm just going to talk you through this. You would find velocity, then you would find the derivative of that acceleration, and then you would plug in 6. That's a real easy one. Can I say that that's an easy one? Find velocity, do a derivative, do another derivative, plug in 6. Okay. Oh, now we're using a graph. Velocity is shown. Oh, I usually say, what did they give you? They gave you velocity. Change direction. Oh, this is the one I skipped it on the calculator part because I said there's another one like this. At what time do we change direction? Well, just 3. That's an endpoint, so 3. And it'll be multiple choice, so you can't mess it up. 3 is it. Do you guys see that there? Remember Karen with a C for getting her homework. Remember that one, okay? Using the same graph, when is the speed increasing? That means velocity and acceleration are the same sign. So look at this first section. Above sea level, so it's positive and increasing. Positive and increasing. So we want that section, 0 to 2. This next section is still above sea level. It's positive, but decreasing. That's opposite. All right. Next section, negative, because it's below sea level, and negative and decreasing means they're the same. So we want that section. And then here we have negative and increasing. That's opposite. So we don't want that section. You guys all just kind of looked at me there. Does that mean that you were all right? Okay. Do you do stuff like that in physics? Is that no? Okay. Just seemed like everybody was okay. All right, using that same graph, write an expression to represent the total distance over time 0 to 6. So you would need to add up all of this positive motion. So you would take wherever you ended up at 3 minus where you were at 0. Do you see what I'm saying? If you subtract those, it'll give you all that positive motion. So x of 3, whoops, minus x of 0. If you subtract those, that gives you the difference in between. Plus, now I need to add up this motion, which means I'm going to have to subtract those. And you're probably thinking it's x of 6 minus x of 3. It's actually the other way around. And why would that be? Because it's negative. Good. So it would be x of 3 minus x of 6. But you're just adding up the motion. You're adding up how far it went. It'll be multiple choice. I promise you'll be able to pick the answer. You'll look at it and go, oh, it's that one. Okay. Cool. I've got like 10 more minutes. We can do it. All right. What did they give you for 14? Position. When is the particle's speed decreasing? That means you need both. Okay, cool. You guys are doing well with that. Velocity. All right. What's the derivative of that thing? 4t squared. Good. Minus 24t plus 32. I'm going to leave a little blank space. Come down here and do acceleration. We'll just go ahead and do the next derivative. So what's the derivative of that? AT, or did you do this one already? Nice job. Some number lines are in our future here. All right, now it's algebra. That's literally all the calculus is doing those derivatives. Now it's a whole bunch of algebra. These will all divide by 4. And then that would factor into what? Perfect. And then these will both divide by 8. So t minus 3. And if you can pick the answer without doing this, do that. Like less work is always good. I just can't do it without a number line. So I make a number line for velocity, a number line for acceleration. We don't do negative time. Did it get capped anywhere? Sometimes they'll do that, like 0 to whatever. No, okay, I guess to infinity. On velocity, I need 2 and 4. Acceleration, I need 3. And do you see how I went 2, 3, 4, counting? And then you just pick a test number, but they're going to alternate. Like if you try 1 in velocity, 1 minus 2, negative, 1 minus 4, negative. A negative times a negative is positive, and it's going to alternate, I promise. And then what's this one going to do? Negative to positive. So I'm going to draw in my little balloon strings. Go ahead.
What number are you plugging? Like, what are you plugging into?
Anything that's in that section. So like from 0 to 2, I would plug in 1 to test that section.
To the t minus 2 or?
Yeah, the whole thing.
Okay.
And so like, you don't have to figure out what number it actually is, just if it's positive or negative. So like if I plug in 1 minus 2 is negative, 1 minus 4 is negative, a negative times a negative is positive. You don't need to figure it out so intricately, just positive or negative. All right, I forgot what we wanted at this point. What do we want? Speed is, okay, so that means opposite signs. So that would mean 0 to 2, and then where else? 3 to 4. Good. You guys are good with them number lines. Oops. All right, these last two, are these the ones with parts? These are the ones that are the free response. Everything up till now was multiple choice. These are the ones that'll be like the free response. You're given particle M and particle N. Are they both position? Sometimes they'll give you position for one and velocity for the other, just as a heads up, just to keep you juggling. All right, these are both position, intervals 0 to 8. When is particle N moving left? That's when velocity is negative. Okay, so N is this one. Let's get our velocity. What would be that derivative? 2t squared? 14t plus 20. They'll all divide by 2. I'm sorry, guys. Can't change what people are doing in the hallway. That would be t minus 2, t minus 5. If we make our number line from, what is it, 0 to 8, they capped it that time. I need a 2 and I need a 5. It's going to alternate, I promise. Just pick a test number. So like if you try 1, 1 minus 2, negative, 1 minus 5, negative, a negative times a negative, positive. And then which section do you want? Moving to the left. Yep, 2 to 5. Looks like an ordered pair, but it's not. There were ones exactly like that in the Delta math.
So the number line being justified.
There was one where they actually gave a point for the sign chart, which is weird. I've never seen that before. I can't remember which one it was, but yeah, that's like the justification. But it actually didn't say justify in this one, so in that case, you don't even have to. All right, when do the two particles travel in the same direction? Well, we found the directions for this one. What was that, n? Now we just need to do the same thing for m. So let's get the velocity for m. What is your derivative for sine? Cosine. So it'll be 3 cosine. Do you need to go get some water?
I'm good.
So 3 cosine of what is it? Pi over 6t times pi over 6. So if you were to multiply these together, 3 pi over 6, that would be pi over 2 cosine pi over 6t. We need to set that equal to 0 to make a sign chart, to like figure out like what numbers are going to go on our sign chart. You can kind of just ignore this first part. Think about your unit circle. We're looking for values where cosine is 0. So where would cosine be 0? Cosine's the x value. So up and down. I don't think we'll need to go any further. Pi over 2 is up at the top. The pi's cancel, but you would have to multiply over the 6. So if you multiply both sides by 6, 6 divided by 2 would be 3. Like if you times by 6. You know what I'm saying? Okay. So we're gonna make our number line. Go ahead. Are you sure? So pick a number between 0 and 3. Let's do 1. That'll be easiest. If you plug 1 into this, 1 times pi over 6, pi over 6. Just what quadrant is pi over 6 in? Everything's positive in the first quadrant, okay? And then it's going to turn negative. They always alternate. Now, yeah, it's going to alternate. I promise it will. Because what does sine and cosine look like? All right, now this is kind of tricky because I don't have these next to each other. It says, when do they travel in the same direction? So from 0 to 2, this one's positive direction. From 0 to 2 would be in here. This one is also, okay, so we want 0 to 2. From 2 to 3, you kind of have to imagine 3 in there. From 2 to 3, this one's negative direction. From 2 to 3, positive. So we don't want that section. How about from 3 to 5? What do you think? Yes? And then 5 to 8? No. It's tough because you have to look at 2 number lines at the same time. All right, is particle m speeding up, slowing down, or neither at time 5? I will just have to talk you through this one. You would do velocity at 5. You would do acceleration at 5. And you do not need to figure out what they exactly are. You just need to do positive, negative. Do you get what I'm saying? Don't worry about what it actually is. Just positive or negative. And then for the justify, it's either going to be same direction, or I'm sorry. It's either going to be speeding up because why? What would justify speeding up? Same sign, slowing down, opposite sign. That's all you got to do. Thank you so much. Yeah. So that was from 9 minutes ago. You can go ahead and go. I'll do these and then I'll real quick pass it up. All right. What did they give you for this one? Position, they want at rest. So how would you do that? Velocity, good. Oh my gosh, you guys got it. Perfect. Okay, what's our velocity? Good. Minus 42t plus 15 equals 0. Those will all divide by anything bigger than 3? No, I guess 3 is it. 8t squared minus 14t plus 5. I'm going to guess this is 4 and 2. I don't know what it is off the top of my head. Is it 5 and let's see. That's 8.
1.
Oh, that should be a 1. What I get for rushing. 4 and 10. Good. And they're both negative. What do you do if you get a negative time? throw it out. You do not do negative time. All right, so this would be time 5/4 and time 1/2. I think, in my opinion, that is the easiest free response question you can get. Find the derivative, set it. It's mostly an algebra question, to be honest. All right, and then this one, please try to ignore them. Using that same equation, so this one right here, total distance traveled from 0 to 1. So you are going to set up a position chart. You're going to put in 0 and 1, and then any of the previous answers where you had it at rest. Now we can leave off 5/4. I only need to put the 1/2 on here. Why can I ignore 5/4? It's above 1, okay? You're going to plug those into position. So if you plug in 0 to this position, what do you get? 1, good. I'll come back to the 1/2 because that one's going to be yucky. If we plug in 1, let's see, that would be 8 minus 21 plus 15 plus 1. That is not a calculator, and be aware, I've seen ones worse than that. Okay, you got to be able to do it without a calculator. So what is that going to be? 3. Negative 21 plus 15 would be -6. 2 plus 1, 3. Okay, cool. I'm sorry, you got to be able to do it. And then we're going to do the same thing with the 1/2. So if you plug in a half cubed. Well, what's 2 cubed, guys? 8, so it'd be 1/8 times 8, 1, good, minus a half squared would be a 1/4, so 21/4, hold on, we'll be okay, plus 15/2 plus 1. If you want to fight your way through that, you need a common denominator, which would be 4. I'm gonna have to come over here. 1 would be 4/4 minus 21/4 plus there. Okay, good. You guys understand fractions. I love it. And then 4/4. So if you add all that up, that'd be 38 minus 21. So 17/4. It comes out nicer on the quiz. Do you guys understand that, like, I get the quiz questions from AP Classroom and then I have to make up one similar and it's hard for me to make it turn. It'll be nicer on there. I think it's a something 0.5 and it's a littler number. Okay. But here's what you're going to do. It starts at 1. It goes to 17/4. And then it comes back to 3. And so you would add up that motion. Maybe we should do the decimal instead. What is 17/4 isn't that, well, it'd be 4 point something, right? 4.25. So, oh, that'll be easier. If you go from 1 to 4.25, that's 3.25. And then if you go from 4.25 back to 3, that's 1.25. Because that actually wasn't too bad. There I was freaking out about it. What is that, 4.5? So you just add up the, like, amounts that it moved.